Lesson 6.5, more two-step equations. Okay, if we look at example A, this is another example of a two-step equation. So we have 2 times the quantity x plus 4 equals 20. Now there's 2 different ways we can solve these. I'm going to use method 1 first. So for letter A, I know that I am taking 2 times the quantity x plus 4. So I know I'm multiplying, so I can do the opposite of multiplying, which is dividing. So I can, first of all, divide both sides by 2. My 2 simplify down to 1. Now I have x plus 4 equals 10. Now I'm down to my one-step equation. I have x plus 4 equals 10. I know that I'm adding 4, so do the opposite of adding is subtracting. If I subtract 4 on one side, I have to subtract 4 on the other side. So x equals 6. Okay, another way we can do this, if we look at example B, we have 3 times the quantity b minus 6 equals 12. We know that when we see a term outside a set of parentheses, that we can use the distributive property. So we can take the term outside the parentheses times everything inside. So if I distribute my 3, I take 3 times b, which is 3b, minus 3 times 6, which is 18, and that equals 12. Now we have a two-step equation like we solved the other day. So first I'm going to bring over my constant. Since I am subtracting 18, I'm going to add 18 to both sides. So I have 3b equals 30. And then since I'm taking 3 times b, I'm going to do the opposite of multiplying, which is dividing. So if I divide one side by 3, I have to divide the other side by 3. So b equals 10. Okay, again on letter C, I have negative 7 times the quantity 6 plus d equals 49. So I'm going to use method 1 again. I know I'm taking negative 7 times this quantity, so the opposite of multiplying is dividing, so I'm going to divide both sides by negative 7. So then I get 6 plus d equals negative 7, because a positive divided by a negative is a negative. Now I need to solve for d, so I'm down to my one-step equation. I have 6 plus d equals negative 7. I need to bring this 6 over. When I look at the 6, it is positive, so I need to do the opposite of positive, which is negative. So I'm going to subtract 6 from both sides. So d equals negative 13. Okay, we're going to do the exact same thing even if we have rational coefficients. So whether we have whole numbers, fractions, or decimals, we're going to use the same concepts. So if I look at letter E, I have 75 hundredths times the quantity 6 plus d equals 12. I'm going to use method 2 again. So I'm going to distribute the 75 hundredths in. So 75 hundredths times 6 is 4 5/10, plus 75 hundredths times d is 75 hundredths d, that equals 12. When I'm down to my two-step equation, now I need to bring over my constant, then my coefficient. So since my 4 5/10 is a positive, I'm going to subtract 4 5/10 from both sides. So now on the left-hand side, I have 75 hundredths d equals 12 minus 4 5/10 is 7 5/10. Okay, now I'm down to my one-step equation. I still need to solve for d. Since I'm taking 75 hundredths times d, I'm going to divide by 75 hundredths. And I get d equals 10. Okay, if we look at letter F, we have the quantity t plus 3 times 5/9 equals 40. So again, I know I'm taking 5/9 times my quantity, so I can get rid of that first. So since I'm multiplying, the opposite of multiplying is dividing, so I'm going to divide both sides by 5/9. That simplifies down to 1. Now I have t plus 3 equals, on the right-hand side, I've created a complex fraction. So again, when we solve a complex fraction, I take my numerator, and I'm going to put it over 1, divided by my denominator. When we divide fractions, we multiply by the reciprocal. I'm going to cross simplify before I start, so I know 5 can go into 40 and 5, goes into 40 8 times, goes into 5 once, so I multiply straight across. 8 times 9 is 72, 1 times 1 is 1, so I simplify that and I get 72. Now I'm down to my one-step equation. I have t plus 3 equals 72. I need to get rid of that 3. Since I'm adding 3, I'm going to subtract 3 from both sides. So I have t, my 3's cancel, and 72 minus 3 is 69. Okay? The last thing we're going to do is we're actually going to write these equations again. So if we look at example 5, Mr. Sang has 3 sheets of stickers. He gave 20 stickers from each sheet to his students and has 12 total stickers left. Write and solve an equation to find how many stickers were originally on each sheet. Okay, so again, I need to pick out what do I know, what don't I know. Well, I know that we have 3 sheets of stickers. He gave 20 from each sheet to his students, and he has 12 total stickers left. Okay, so I need to figure out, I don't know how many stickers are on each sheet. That's my variable, is S. But I know I gave away 20 from each sheet. So I'm going to take how many stickers are on a sheet minus 20. All right, and then I know I have 3 sheets, so I'm going to take that times 3. And that's going to equal the 12 total stickers I have left. So again, I don't know how many stickers are on a sheet. I know I took 20 away from each sheet. So I'm going to take that quantity times 3 because I have 3 sheets. And then that should equal the 12 stickers that are left. After we have set up our equation, now we're going to solve it. So I have 3 times the quantity S minus 20 equals 12. Okay, so again, I know I'm taking 3 times the quantity, so I'm going to divide both sides by 3. Cancel, so I have S minus 20 equals 4. Since I'm subtracting 20, I'm going to add 20 to both sides. So S equals 24. So each sheet started off with 24 stickers.